Many farmers treat organic matter and humus as the same thing, assuming any biological material added to a field automatically turns into long-term soil health. But the physical reality of the field often tells a different story. You can add tons of compost and still find yourself holding dry topsoil that falls uselessly through your fingers. This happens because raw organic matter does not perform the same functions as humus. When a grower miscalculates this, they end up with soil that lacks the structural stability to survive a dry season. To fix this, we have to find the specific scientific boundary. We need to identify exactly where the broad category of organic matter ends and the refined substance of humus begins. Making this distinction is the first step in moving past guesswork and towards a soil management strategy that actually sticks. If you look at the surface of a healthy farm, you see a chaotic variety of biological material. Scientists group all this under the umbrella of soil organic matter. This includes everything from fallen leaves and crop residues to animal manure. It also includes the living biology, the microscopic organisms in the dirt and the root systems currently growing through the rows. Think of soil organic matter as a massive biological catch-all. It is the total sum of every unrefined organism and piece of debris within the soil. The problem is that most of this material is temporary. Because it hasn't finished decomposing, it is highly volatile. These inputs rot away quickly, disappearing before they can provide any long-term benefit. This rapid decay means that raw organic matter cannot provide the stable, lasting architecture that soil needs to remain productive year after year. To create that stability, the soil uses a biological filter, decomposition. Microorganisms relentlessly consume raw materials, stripping away their original physical structures. During this process, a leaf loses its shape. The cell walls break down and the veins dissolve into the earth, until the material is no longer recognizable. Eventually, the microbes can no longer extract energy from what remains. The decomposition process reaches a point where only the most resistant molecules are left behind. This animation shows how organic matter distills into a dense, dark core. This final concentrated remnant is humus. While raw leaves rot in weeks, this material is incredibly stable. It remains in the soil, unchanging, for decades or centuries. Humus represents the final stage of biological breakdown, functioning as a stable chemical anchor that lasts long after the original organic matter has vanished. Now that we have isolated this specific fraction, we can see why it is the most valuable component of any field. First, the physical structure of humus pulls water in like a high-density sponge, holding massive amounts of moisture without causing surface runoff. It behaves like a chemical volt. Humus particles carry a charge that attracts nutrients like potassium and calcium, locking them in place. Plant roots easily navigate this porous structure, pulling nutrients directly from these stored reserves. We began with a chaotic mix of raw biological inputs. By tracing the decomposition process to its final stage, we arrive at the material responsible for long-term soil structure. This diagram illustrates the crucial subset logic. All humus is organic matter, but only a small fraction of organic matter ever becomes humus. Understanding this distinction allows a grower to look at their land and accurately predict which inputs will disappear and which will stay to build the soil for the next generation.